So in this textbook, they define something called a wrapping function. It goes like this: W of t is equal to pxy, and you look at that and think, huh? What the? Well, look, let's go back, and this time, let me get my pen going here. Let's say that we're talking about some coordinate point on this graph. This is our point P, right, xy. What could we say about it? Well, as we were stating, in fact, that this point P is related to the arc length T along the edge of this unit circle, right? And of course, as we said before, the arc length T is equal to theta. So we're replacing the central angle theta with the arc length T whenever we're dealing with this unit circle. So what could we say about it? Well, we had just previously defined in our last video here that sine of t is equal to y, and that cosine of t is equal to x. Okay, so in fact, WT, this is what we call a parametric function. A parametric function. What a parametric function is that we define one variable, t, in terms of two others, x and y, or should we say x and y is defined in terms of one variable, right? So in other words, what we're saying is that, well, okay, whatever my point P is, my point P, which is xy, is always equal to the coordinate point made up of the cosine of the angle t and the sine of the angle, the arc length t, right? So for example, what are we saying here? Well, if we had a arc length of 0, what would happen? Well, as defined by our quadrantial angles back in section 5.3, this is the coordinate point 1, 0. So what does that say? Well, W of 0 is going to be the coordinate point 1, 0. And we know that what we're really saying here is that, well, then the cosine of 0 is equal to 1, but we already knew that, and that the sine of 0 is equal to 0. But again, we already knew that part too, right, due to our definitions of those quadrantial angles. So what else could we say? Well, if we're evaluating our wrapping function then at pi over 6, what we're really looking for is the coordinate point that's made up of the cosine of pi over 6, which we happen to know to be radical 3 over 2, and the y value, which is the sine of t, and that happens to be 1/2. If we said w of p over 4, or pi over 4, what are we really talking about? Well, in this case, that is going to be both the sine and the cosine, right? So the cosine of pi over 4, that turned out to be radical 2 over 2. And the sine of pi over 4, that ends up also being radical 2 over 2. If you're looking at this unit circle, you can almost think of it this way. If we pick a point like, let's say, pi over 4, arc length of pi over 4 is associated with a coordinate point at square root of 2 over 2, square root of 2 over 2. Those are the xy coordinates found by taking the cosine and the sine, respectively, of that arc length pi over 4. And we could just continue on down the line. The wrapping function of pi over 3 is equivalent to asking for the cosine and then the sine as our coordinates. That is 1/2 and square root of 3 over 2. As we also learned in our earlier section right here, 5.3, that at pi over 2 we do have a coordinate there, an x and y coordinate, where we have 0 and 1. So w of pi over 2 is the point 0, 1. And again, we would know that the cosine of pi over 2 ends up being 0, and that the sine of pi over 2 ends up being equal to 1. Okay. How about pi? Well, at pi, we get the coordinate negative 1, 0. So that is w of pi. W of pi, our wrapping function at pi, is going to be the point 1, 0. Negative 1, 0. Pardon me. The negatives do count here because that's where we're located on our coordinate axis. Right? 3 pi over 2, that's associated with a coordinate point here at 0, negative 1. So our wrapping function there will be 0, negative 1. And of course, 2 pi, we return back to where we were all the way back at the beginning. So our wrapping function for 2 pi, well, that's nothing more than saying 1, 0 again, and then we start the process all over again. So if we're looking for a wrapping function, we're just simply looking for the coordinate point associated with that particular arc length. That's it. All right, more to come.